Hi everyone and welcome back to the channel. I'm the GCSE science teacher. Today we're going to be talking about the national grid for GCSE Physics, specifically the electricity topic. So let's get into it. First of all, what actually is the national grid? Well, essentially what it is it provides electricity to homes and buildings across the country by connecting them to power stations. Now remember, power stations are places that essentially break down or burn fossil fuels to release the energy found within them. So this could be the coal, the oil, natural gas, but also it could even be power stations that use nuclear fuel or even renewable energy resources as well. Now, the national grid is really useful because if one power station breaks, the grid actually continues to supply electricity because it will draw power from another power station nearby within the grid. So, essentially, it's a really good way of connecting all of the country together and supplying the consumer, such as ourselves, with electricity. Now, you need to know for GCSE what the national grid consists of and a bit more information about each individual component. So, let's have a look at that now. So as you can see here, the national grid as a snapshot image, you can see that the electricity is generated from a power station and the electricity is transferred through step up and step down transformers. I'll discuss what those are in a moment. But also the electricity is passing at a very, very high voltage, especially during the transmission cable stage. This is essentially where the electricity is being channeled through to the home, and it can be at incredibly large distances. So that's why those transmission cables are there, and I'll talk about those in more detail as well in a moment. And then when it reaches us, you can see that the voltage decreases to 230 volts, which is more of a safe, much lower voltage. And I want to talk to you now about why the voltage is so high at the beginning, 400,000 volts, and much lower when it does reach our home. So let's talk about that now. So, although we may have heard of transformers as a type of robot, actually, transformers in physics are really useful, especially in the electricity world, because they have the ability to change the voltage in a system. So, a transformer itself is made of an electromagnet, a piece of metal that is magnetic and it has coils of wire around it. When a transformer is utilized in the national grid, we actually have two different types. We have a step up transformer, which has much more secondary coils to them. This essentially makes the voltage much higher. So this is at the beginning. The voltage is increased, by the way, so the current is actually reduced. And this is because if there's too high a current, it will actually increase the heat that is generated, and that can lead to inefficiencies. So we want to lower the current, and by doing that, we actually have to increase the voltage. And I'll show you the maths behind it. But that's essentially why that's done. So because the electricity is being transferred from a huge distance, remember the national grid essentially supplies electricity to the entire country. We have to essentially transmit alternating current to a very widespread area. We want to make sure that it's very efficient. I did do a video about alternating and direct current, and how that came about, so I'll link that for you. But that's why this is being done. So the transformer at the very beginning is a step up transformer because it's essentially trying to increase the voltage to decrease the current and reduce the inefficiencies and heat that is transferred to the surroundings. But we obviously don't want to have really high voltages in our homes because that would be incredibly dangerous. So what we do is we actually step down the voltage when it gets to our homes, and this is what we use. We use a step down transformer. There are less coils of wire in the secondary coil, and that basically reduces the voltage to 230 from a previous 400,000 volts. So, just to give you some maths behind this idea that voltage and current are inversely related to one another, they're inversely proportional. Remember the equation V equals IR. I've actually rearranged it to R equals V over I, or voltage or potential difference divided by current. We can see that if we increase the voltage, we actually decrease the current. And that's essentially what we want to do. By decreasing the current, we are actually reducing the amount of energy in terms of thermal energy that is dissipated to the environment, meaning that it's a lot more efficient when transferring or transmitting that electricity to a huge, widespread area in the country. Another way to help with this is to use very thick cables, which actually reduce the resistance. We also have, like I said, very high voltages to reduce the current, but also like I mentioned previously, the pylons that are used to hold those cables above the ground. Remember, because they have such high voltages, those cables are going to be incredibly dangerous. So we want to make sure that they are above ground, but also far away from anybody as well. So they're often placed in fields. You may even see them on the motorway, like I said. So they're far away from anybody in case, in case anyone was near one, they're high above ground as well. Okay, so that's it from me. Thank you very much for your time. If you did enjoy the video, feel free to give it a like. I've been the GCSE science teacher and you have been curious. I have also other videos over on this side of the screen, which you can click on if you're interested. And I also have other social medias on this side, TikTok and Instagram, which you can explore at your own leisure as well. Until next time, I hope you have a fantastic day and I'll see you soon. Take care. Bye.